Welcome back to another video. In today's video, we will be looking at creating a Twitter sentiment analysis project. Just as a disclaimer, I will not be using the live data from Twitter. Instead, I am taking the Twitter data that is already available on Kaggle so that you can follow along with this video. But don't worry, the implementation part is almost the same, except that for the live data, you need to add in some more lines of code for pulling the data from Twitter. So, getting back to our project, what we are going to do is that we are trying to find the sentiments of people towards a particular topic, which in this case is COVID vaccines, as our dataset consists of tweets related to COVID-19 vaccines. Oh, and by the way, if you like my content and want to see more videos, please do hit that like button and smash that subscribe button as it encourages me to keep making new content. Stay tuned. So first, let's import the required libraries. So, we are importing Pandas and NumPy for basic data operations. We are importing RE to use the regex function. We are importing cbonds and matplotlib for visualizing the data. Then we are importing style to set style for our plots. And here we are using ggplot, and you can use any other style of your choice. Then we are importing textblob to process the textual data. Then we are importing word tokenize to perform tokenization. Then we are importing porter stemmer to perform stemming. Then we are importing stop words to remove the stop words, and then we are setting the stop words as English. Then we are importing WordCloud to plot the word clouds. Then we are importing count vectorizer to vectorize a text document. Then we are importing train test split to split the data into training and testing data. Then we are importing logistic regression to perform logistic regression. And then we are importing the different evaluation matrices used to evaluate the model. And by the way, if you want to know more about different NLP topics such as tokenization, stemming, etc., I highly suggest you check out my video on this topic in the NLP playlist. I'll add all the links in the description down below. Now that we have loaded the libraries, let's load the data. Now let's use a head function to preview the data. Let's now use the info method to get more information regarding the dataset. And as we can see, there are a lot of columns with null values. Now let's get a count of all the null entries in our dataset. To do that, we can use the sNullSum method. So here we can get a count of all the null entries, but for doing this project, I'm using only the text column. The target or the sentiment column is not provided in the dataset, and we'll be creating it ourselves. So let's drop all the other columns. To drop the unwanted columns, let's first get the column names. So we can do that by typing df.columns. And this will give all the column names. Now let's create a data frame with only the text data column. and specify the access. Let's use a head function to see the new data frame. So now we have a data frame consisting only of the text data. Now let's analyze some of the text data in a data frame. So this is basically the raw data that we got from Twitter. Now we have to use text processing to process this data to make it into a usable format. Let's use the info method once again on the new data frame. Now our data has 11,020 entries. Let's now proceed to process the text data. Data processing is done to make the data into a usable format. There are different steps involved to convert the data into a usable format. You can do them individually on the text data, or what I'm going to do here is to create a function that does all of the text processing, and then I'm going to pass my data into it. So let's define a function. Let's perform lowercase conversion, and then let's remove the URL in our tweets. So here we are removing the URLs using the regex function. Similarly, we are going to remove the hashtag and the punctuations using the regex function as well. And then let's remove the stop words. Let's now apply this pre-processing function on the text data. Let's also remove any duplicate data in the text by using the drop duplicate method. Now there is one more thing to do, that is to perform stemming on the data. Here for this project, I am going to use a porter stemmer. You can also use any other type of stemmer such as the Lancaster stemmer or the snowbird stemmer, or you can even use lemmatization instead of stemming. The Python codes to perform all these are there in my tutorial videos. So now let's perform stemming. So I'm loading porter stemmer and I'm defining a function to perform stemming. Now let's apply stemming to the processed data. Let's now see the processed data using the head function. Let's also analyze the same text as before to see the effects of the pre-processing function. As you can see, our data has been modified. Now let's use the info method once more to see the updated number of columns as the duplicate entries have been removed. And as we can see, the number of columns have reduced to 10,543 from 11,020. Now that our data is pre-processed and ready to be used, let's use text blob to calculate the polarity of the sentences. So let's define a function to calculate the text polarity using text blob. And now let's calculate the polarity of the text and add it to the data frame. Now let's view the data frame using the head function. Now as we can see, a polarity has been added to all of the sentences in a data frame. Now let's add a sentiment column to the data frame. To do that, let's define a function to calculate the sentiment. Now let's apply this function on the data frame. And let's preview the data frame using the head function once more. Let's now visualize the distribution of the data using a count plot. So let's first set the figure size. Now this gives us an indication of the different sentiments in our data. We can also visualize this data using a pie chart. So let's look at how to create an exploded pie chart. Now let's set the color for the three sentiments. Now let's define the line width and the edge color. Now let's specify the different tags in our pie chart. And now let's specify the distance for how much the wedges should be exploded. And then let's plot the pie chart. And finally, let's add a heading to our pie chart. Now we have a visual representation of the distribution of the sentiments. Now let's see the top 5 tweets for each sentiment, starting with a positive sentiment. And let's visualize the data by using the positive tweets head function. Let's now use a WordCloud to visualize all the positive tweets. So you're specifying the height and width to get more clarity for your word clouds. Now if you want to get more detailed explanation about word clouds, or if you want to take your word clouds from this to this, you can check out my video on this topic as well and add links to it in the description down below. So this is a word cloud for apostate tweets. Now similarly, let's see the top 5 tweets in negative sentiment. Now we have some of the negative tweets in our data. Similarly, let's visualize the negative tweets using the word cloud. Now we have a word cloud of the most frequent words in the negative tweets. Similarly, let's do it for the neutral tweets as well. Similarly, let's visualize the neutral tweets using the word cloud. Now we have a word cloud containing the most frequent words in the neutral tweets. So far, we have taken the input data, performed some pre-processing on it, and visualized the processed data. Next, we are going to vectorize that data using count vectorizer. You can also use any other vectorizer such as TF-IDF vectorizer. I have used TF-IDF vectorizer in my hate speech detection project. But before proceeding to build the model, let's create a bigram language model. N-gram language models basically means a sequence of n words. So bigram language model will give you 2 words. More on n-grams in another video. So let's perform count vectorization on the data and create a bigram model. Now let's get the number of features and print the first 20 features. Now as we can see, we get the first 20 features from a bigram language model. Now that we have vectorized the data, let's proceed to build a model. So first we'll have to separate the data into x and y and then transform the x data. And then let's split the data into training and testing data. I'm taking a test size of 20%. Now let's print the size of the training and testing data. So first let's train the data on a logistic regression model. So first let's load the logistic regression model, and then let's fit the X-train and Y-train on the logistic regression model. Let's predict the value for the given test data. And then let's calculate the accuracy for a model. And then let's print the accuracy. So now we have a test accuracy of 84.6%. Now if you want to remove these warnings, you can use a filter warning command. And now let's print the confusion matrix and the classification report. Now there is also another way to visualize a confusion matrix, that is by using the confusion matrix display. Let's look at how to perform that. So first let's set a style for the confusion matrix display. Now we have a more understandable version of the confusion matrix. Now let's see how the accuracy of the model changes when you perform hyperparameter tuning. Hyperparameters are model parameters whose value control the learning rate of the algorithm. So by tweaking the hyperparameters, you can change the performance of the machine learning model. There are different methods by which you can perform hyperparameter tuning. For this project, I am going to use grid_search_cv to perform hyperparameter tuning. First, let's import the grid_search_cv. So here, since we are using the logistic regression algorithm, I'm going to perform hyperparameter tuning on the C parameter. So I'm going to set a couple of C parameter values. Now let's define the grid_search_cv along with the classifier. And now let's fit the data. Now let's print the best parameters. And then let's print the value for the given X test. And then let's calculate the model accuracy to see if there is any change. And then let's print the accuracy score. As we can see, there's a slight improvement in the model accuracy. Now let's print the confusion matrix and the classification report. So this is the updated confusion matrix and the classification report. Now let's run the model on one more algorithm, the support vector machine. To do that, let's import the support vector classifier. And then let's load the classifier and fit the data on this model. Now let's predict the values for a given test data. Then let's calculate the accuracy. And let's print the accuracy. Okay, the SVM model gave a better accuracy than the logistic regression model. And now let's print the confusion matrix and the classification report. Similarly, let's perform hyperparameter tuning for the SVM model. So let's go ahead and define the parameters for the SVM model. Let's now define the grid search just like we did for the logistic regression model. And then let's fill the data. Now let's put in the best parameter. And then let's predict the value for the given X test. And now let's calculate the model accuracy to see if there is any change. Now let's print the accuracy. So as we can see, there is a slight improvement in the model accuracy. Now let's put in the confusion matrix in the classification report. Now if we compare all the model accuracies, we can see that the hyperparameter tuned SVM model gives the best model accuracy. That brings us to the end of this video. Hope you got an idea of implementing sentiment analysis on Twitter data. Don't forget to subscribe to this channel and share this video with others if you found this video useful. Thank you for watching and see you in the next video.